Hello everybody, and welcome to the next lecture in our course. And what we're looking at today is Introduction to Labview. Now I'll just start this from the beginning so you can see everything that I'm talking about here. Labview is a graphical programming language. So what does that mean? Well, what it means is that we're talking about virtual instruments rather than subroutines. And there are several things you need to be aware of when you get an introduction to Labview. The main components of the system you'll see in the National Instruments software are the front panel, the block diagram, the icon, and the connector plane. Now, the front panel is like, well, the reason they call it a front panel is it's like a front panel on an instrument. In other words, it has readings, dials reading out values, and it has controls. Indicators, they call them, indicators and controls. Whereas the block diagram shows you the actual code that controls how the VI works. The icons they can represent controls or indicators, and they can indicate really functions as well. So they do things for you. They're like subroutines themselves that do things for you. And the system's hierarchical. So if you see an icon, you can double click on it and see how that works. And you can go up and down through them. You can tell the difference, by the way, between a control and an indicator, in that control has a thicker outline. The indicator has, as you can see, a sort of a hollow outline there. The important thing to realize really with a graphical programming language like Labview is that the control of the language is through data flow along these wires that connect these different icons together. This icon is simply an addition, so it just adds together the two numbers and gives you an output. The color of these wires indicates the type of value that you're dealing with. So in this case, you can see it's orange, and that indicates it's a floating point number. If it was blue, that would have indicated an integer. So the front panel is the user interface of the VI. It specifies the inputs and displays the outputs of the VI as it says there. There's a few things on the front panel which I will describe later on. This is the way that the icon appears, the appearance it's got in the block diagram. That's the icon, if you like. This runs the program, or the VI. This runs it continuously, stops it. So you'll go through all these functions, they're fairly straightforward. The block diagram, as I just mentioned, contains the graphical source code composed of nodes, terminals, and wires. And this looks a little bit complicated, but you'll understand how it works after a while. This is some icons, some VIs that come with the iMac Vision tools. This is iMac Create here, which creates some memory, or allocates some memory in the computer to store an image. This is display VIs. This displays an image for you, and we'll use this for the assignment. In the block diagram, use the tools palette to create, modify, and debug VIs. So when you're in the block diagram, you just press your Shift key and right-click to display a temporary version of the tools palette wherever the location of the cursor happens to be. Now these different functions or different things you can do with the tools palette are indicative of Labview. This one allows you to manipulate things. This is a wiring tool, which you'll use a lot. I'll explain. This allows you to put a probe in, which just gives you a reading of what the value is on a wire at any given point, and so on. This allows you to move around icons on the screen to develop your VI. The controls palette is where you place your controls and indicators on the front panel. So you right-click on an open area of the front panel to display the controls palette. So this is an indicator, an LED indicator. And for example, this is a numerical control like a knob you can rotate to give different values. You've got switches and buttons and graphical indicators and all sorts of different things. Use the functions palette to build the block diagram. So when you're in the block diagram, you right click on an open area and up comes the functions palette. And this contains all the functions we can do different things with, which is how you control your program. This will all become clear when you start using it, really. Now the help menu is quite useful, particularly something called context help, which I'll show you in a minute. So context help is where you turn it on, and then when you hover the cursor over the top of the of an icon, it tells you what that icon or VI does, tells you what the function is. And by clicking on the detailed help, you can get more information, more detailed information on exactly what it's doing. So this is iMac Create, I just mentioned a minute ago. And it shows you what the inputs are and what the outputs are. And then you get more help. Now, as I say, these are integers because they're blue, integer values. You see these are sort of broader. That's because they're generally images. So image obviously consists of lots of numbers, not just one. So it's going to be what they call a cluster. You can think of a cluster as like in a factory, say, where you would have one wire going somewhere doing something. But if you had lots of wires to do something more complicated, maybe control a robot, you'd have them inside, probably inside a plastic container containing sort of protection. And that would be a cluster. So you can uncluster all the wires or you can cluster them together depending on what you want to do. It's the same with Labview. All the objects, all the Labview objects on the front panel and block diagram have associated shortcut menus, which you access by right-clicking an object on the front panel of the block diagram. So you right-click on it, and you can do all sorts of different interesting things by means of using this right-click. One thing you'll do, which I think is particularly useful, is create. So when you want to wire things together, and you'll see this when you'll understand more when you do it. But if you wanted to have an output of some sort and you want to connect it to an input, you could do it by wiring it using the wiring tool. But you could also just right-click on the output and select create, and then it allows you to create different things, sort of constants or controls, and then you can create them. And the advantage of that is it's a little bit less work for you, and also you know that the integer type connecting it together will be correct. So you'll practice doing this later on. On the front panel, with controls indicators, which are the interactive input and output terminals of the VI respectively. This is a frequency response graph that someone's drawn. The great advantage of Labview is it's designed to be easy to use. So in other programming languages years ago, we used to have to write code to display anything like this. But this is all taken care of by the Labview National Instruments software. So all you need to do is select, you've got to create an indicator, and up it comes. You just create it very easily without any problems at all, without you required to do any programming. So again, it's about you getting the functionality you want from it without having to go into all the idiosyncrasies of the programming like you do in C. So as it says there, control terminals have a thicker border than indicator terminals. Another thing you can do is you can change a control to indicator or change the indicator to control, again, just by right-clicking on the object and selecting change to indicator or change to control from the shortcut menu. So you can change the type of thing you've got on the screen very easily doing that. Now, as I say, the block diagram is composed of nodes, terminals, and wires. And this is a program someone's written to do some vision display. So it looks a bit busy, but you'll understand what it all means. These icons here, these three, have got to do with a type of image acquisition called acquire. So someone's decided they want to use acquire to acquire some images, capture images in other words, and this sort of synchronizes and sets it up for them using these things. Again, iMac Create simply is allocating memory in the computer to where you store the image. By the way, it's always good practice to, if you're going to use iMac Create, to correspondingly use something called iMac Destroy. Because if you don't and you keep running the program, it'll keep allocating memory, and eventually the computer will freeze because there'll be so much memory allocated, there won't be anything left to do for the computer operate. So it'd be good practice, and for some reason someone hasn't done that here, maybe just as it's a quick demo. Now, you see this here, this is the way you do looping in Labview. So you create this structure, they call it, and again you get it from a menu, and it goes through a loop. you get the number of iterations, number of times it's gone through the loop there, and you can control whether it carries on going through the loop. So like a while loop will carry on until it gets a Boolean false going to this control. So you can also use Boolean logic in Labview, and all the Boolean stuff is there, and NAND, and all the rest of it. True, false inputs, and so on. This over here is an error control coding, which you just connect up, and it helps you. Another advantage of Labview is it tells you if there's a problem, really where the problem is. It doesn't just give you a general error message. It tells you exactly specifically what's going wrong. I'll show you that. So in this very simple example here, we've got two numbers added together. And as you can see, there are two controls, X and Y, and one indicator, X plus Y. And you're just using an addition operator here to add those two numbers together. On the front panel, we've got the indicators here. As you can see, it's just reading a number out. The controls with the thicker border are here, and you can see you've got some little buttons to control the actual values here. So these are controls, and that's an indicator. So the idea is that, the person using the VI doesn't really want to bother with all this detailed, busy code. He just wants to use it in terms of an instrument and easily without any problems in the VI. This over here in the block diagram, it's got to do with debugging, which I mentioned a minute ago. So you can create a probe, which is a bit like a print command you might have used years ago in a basic program. But the probe just reads out what the value is in the wire at any point that you're particularly interested in. Then you can control operation a little bit, slow things down a bit if you're trying to work out what's going on. Maybe there's a problem somewhere. By means of the step over commands and step through commands, so just take a step at a time. This is a good, quite useful function, a debug. So what it does is it runs the program very slowly, and it prints out continuously what the values are traveling along the wires. So that helps you to see if everything's progressing, as you expected it to. Now, the operating tool is what we use to configure the front panel and the indicators. The positioning tool, so that's the operating tool here, you see, this little hand. Click on that. Positioning tool is this arrow here. So you use it to select, move, and resize objects, as it says there. And then the wiring tool is where you wire together objects on the block diagram. And there we have, it looks like a spool of wire. Of course, the actually operative sort of little point is the tip of the finger there, the tip of the arrow, and of course the tip of this wire here. These are the functions you could do things we're talking about, like probes and so on there. You can use the search buttons on the control and functions palette to search for controls, VIs, and functions. That's quite useful because you may be looking, obviously, Labview's got many, many different functions available, and you don't necessarily want to search through all of it, just to look through all of it just to find something. So you can do a quick search and find something. So different types of functions here, controlling the program, input, output, and so on. Now, when you run you're rigging up a program, you're wiring together these icons. You might find that sometimes you get this dotted line appearing. Now, that indicates a broken wire, and the program won't run. It shows it won't run by means of giving you this arrow with a broken arrow here. So what can you do about that? Well, the best thing you can do about it is to search through and find this broken wire and delete it. There is a function that removes all broken wires, but I don't recommend that you use that because there might be more than one, and there might be something going on. I mean, if there's a broken wire, something's happening that wasn't really expected. So rather than do that, which may lead to other problems because you didn't understand what was happening, it's better to go through and sort it out yourself, really. And the broken run button, if you try to run it, it will come up with the error list window, which tells you all the errors that you've got in the program. In fact, it tells you the wire has loose ends here. Execution highlighting, which is really what I was talking about. Single stepping, that's this mode here, debug mode. Single stepping and the probes to animate the flow of data through the block diagram, which is kind of useful. Another thing you want to do, especially in the assignment, which requires you to do a bit of Labview programming, is to put some comments in. So you can right click and put help associated with any kind of VI that you create. You can create your own help to go with it. Or you can just write things on the block diagram to explain what's happening at various points. And this will help me when I come to mark the assignment. And also you can use it and print it out in the document that you submit, showing what's being shown at various points and what's happening. So that is a basic introduction to where we're going to with with Labview. If I just go now to start up National Instruments software, maybe I'll start at the beginning. I'll shut this down and start right from the beginning for you. Let's see. You go to the menu, you'll see National Instruments, Labview, 64-bit, running there. It comes up. It asks you what you want to do, what you want to create. You say you want to create a blank VI, because these things are virtual instruments, like subroutines. Okay. So I just started this up, and I've got this blank VI appearing. Now, as I say, you've got the block diagram and the front panel. You can toggle between them, just move back and forward between them. You can also have them, if you prefer to do it like this, have them on the same screen, just tiled. So if I right click over here, I've got all the functions I was talking about, but it's good practice to start with the front panel really and put some controls or indicators on over here. So I'm just putting a control on there. And you can see the control appears, that's where I control the value I'm putting in to the program. And over here, a corresponding numerical control with the thicker outline has appeared in the block diagram. I can do something with that in terms of connecting it to other things. So if I create another control over here, create another control. So we now have two controls and I can do something with them. I can probably create an indicator over here. Now let's see. I'll keep it simple to start with, I guess, just a numerical indicator. So again, you see that I've got means controlling this, but no means controlling this. So, and the thing's quite clever. It actually changes to operating tool when it hovers over this, so you can start changing the values you've got in these controls here. But I now talk about the context help here, and the context help is turned on. There it is. It's turned on and off here, so it's disappeared there. You see. But probably a good idea, generally speaking, to keep context help on. And then you can really see what's going on with this with these VIs. Now I've got to do something, so I'll just right click again, and I want to go into the numerical control comparison here. Okay, so but I really want to go for a numerical actually. I want to add a couple of numbers together. So this is a like function which just simply adds two together. So I'll put it in the middle there. You can see again when I hover over it, it's turned into the wiring tool because it thinks I want to connect things to it, which is true. And it's also showing me the contacts on there. So you can move these things around the screen wherever you want. These are windows to give you an idea what's going on. I'll just this up here is quite interesting. This shows how the icon will appear. This little subroutine, or VI if you like, will appear if I insert it, if I save it and insert it in another program. It would appear like that. That would be what my VI would appear like. And this is the connector pane where you connect, you tell it where these inputs will be connected to on your VI. This is just the default way it starts. This is very simple, so it only have 3 in this case. So what I want to do is I want to connect together this value here, okay, into this function here. So I'm just going to add these two numbers together. So I'm coming through here. So I'm connecting it through. Just go in there like that. Going straight into there. Now I'll connect. It's quite fun fooling around with this actually. It's quite a nice way to program. So we've got it all connected together. It's even told me that I'm dealing with floating point numbers. And so I could probably have a go at running this. It's very, very simple. Obviously 0 comes in, 0 goes out. If I want to change it, it's just adding together these two numbers. Very, very simple example. VI, just to get going onto this. And you can associate these inputs with these contacts. So now I could save this VI. I could save it. I could just save it on the PC somewhere, on the laptop somewhere. Okay. So there we go, and now I've saved it, and you can now see that it's appearing there, and it's got that icon I was talking about, and that's it there. And yeah, so here up come the functions, and you have all your functions. You can do various things. Yeah, so if I just close this down, I just double click on it to open it up. I can open up any VIs I want and save them and do whatever I want here really with these different functions. You can go through this and it's pretty self-explanatory. While we're here, I think one thing that's worth mentioning is that you know, rather than just purely go through the things that, I mean, I will give you a tutorial and put it onto Blackboard to help you get through, to go through the various functions. But one thing that's also very much worth doing is going through yourself to looking for different examples. So if I try and open one, I'll go to Labview. I can just trying to find the ones. What we've got under the National Instruments. Under National Instruments, actually, I think I'll just shut this down. Under the National Instruments directory, I can have a quick look here. National Instruments. Yeah, there we go, National Instruments. Labview, that's the latest version of Labview, you'll have a later version. Examples is what I'm talking about, examples. Now you go on there. Now there's all sorts of examples of different things. So it's definitely worth looking through these and getting an idea of how different things work and exploring them. File input output, for example. Yeah. And here we have reading a binary file in. So this is an example file. You could open this up yourself and you can look at how things work. You can turn on the diagram. This looks a bit busy, but as you see, someone's put a lot of comments here, which is kind of helpful, and they've explained how it goes. And I can also turn on context help and just hover over the top of these icons. Up comes the help. Here we are, open, create, replace file, standard Labview VI, and I can go down there and get more help. And I get more details. I get a load of background. This is useful, actually, if you're really trying to understand how a VI works or what it's really all about. These are telling you all about what the inputs are, you see, and what the outputs are, and what it really does. And there's lots of different functions and different ways of doing things. What we're going to do in the assignment is open up. I'm going to, you know, in a future week, we're going to write a simple little VI for opening up and displaying an image, which will be useful. It will give you a start, really, something to start with. I find that in the assignment, if I give you something to start with, kind of you can build on it, and it's really helpful for students to work that way. So there we go. But you know, it's not just about this kind of thing. When you open it up, this is what you see, by the way, when it opens up. When you open up Labview, but there's all sorts of different help here, or examples here. Now, if I just quickly go into this a little bit more. Yeah, for example, there's a load on vision, which are definitely worth having a look at. And there's, because Labview comes with loads of VIs for doing different things, like reading barcodes and QR codes, calibration, and measurement with calipers, and all sorts really. Display. This is a little function someone's written to demonstrate how you use iMac browser to display multiple thumbnail images. So if I run this, now it's showing me how this works and how I can select different ones just by clicking on them, and that's how that works. I stop it by pushing, not surprisingly, the stop button. This shows it's running continuously. It's running, that's the way they've arranged it to run continuously. And, you know, this looks a bit busy, but we'll go through how it works in future weeks. We'll go through how these things work. This is a while loop, which I talked about a minute ago. Okay, this is also a loop, but it's a for next loop. So it goes through loops according to you know, a certain number of times, depending on what you want. And that's a counter there, and that's a number of times it's going to go through the loop. One thing that's very useful in Labview, which I'll talk about later, is something called auto-indexing. Okay, so if I, you know, an array is just a set of numbers, as you know. If I input an array into a loop like this, it will automatically start auto-indexing. What that means is that it will look at one element of the array, and it will go at a time. So it will go through, suppose I put in an array of just 5 numbers, it would go through 5 times looking at each number in the array, which is very useful and helps you to analyze arrays and images and so on. So you're likely to use that. This is a case structure. So with this, again, it's a square, and whether or not it does what's in the inside the structure depends on whether it gets a true or false Boolean input here. So if it gets a true, it's gonna do what's in here. If it gets a false, it won't. It just won't do anything. If it gets a false, it just sends its numbers through like that. So this is also a little timer here, which simply all that does, okay, is that pauses the program for 50 milliseconds. This is in milliseconds. You see this clock here. So it waits a specific number of milliseconds, as it says there, and returns a value with the millisecond timer. So there are a number of ways of doing these different things, but these are, you know, quite interesting what they've done here. So I don't save. I just shut that down a second. So I'm just going through these functions. It's definitely worth exploring this, and you can't damage anything. You can just go through. You can edit it. You can try running it. You can put inputs and outputs and put context help on. And I think this is a good way to find out more about Labview. Different functionality. There's a lot of image processing. There's image processing, sort of thresholding, image thresholding. That's one of the first things. Image thresholding, where you segment something really. You set all the. You're looking for a feature of interest, and you're trying to threshold it. You're trying to set all the pixels to white in the feature of interest, and everything else to black. Really, and this just shows how different thresholds work that they've got. That they're using here, and so it's a little demonstration of how these different things work, really. So that's the input image, and this is after it's been thresholded according to this threshold that they've got. And of course, Labview comes with lots of different thresholds, different ways of doing things, but which are quite useful and worth exploring. Yeah. So that's the introduction then to Labview. I think that things will make more sense to you when you actually try using it yourself in the tutorial. You go through, just start off very simply. The tutorial is fairly self-explanatory and starts at a fairly basic level, so I don't imagine we'll have any problems. So the idea really I've got is that you get into Labview, start finding out basically how it works, get your head around this idea of graphical programming and doing everything with connecting icons together with wires and having numbers running along there. And that idea is of controlling a program in that way is something which takes a little while to get your head around, but it's worth spending some time on it. So in the block diagram I had a minute ago, with all these different things that are operating here. For example, if I just go back here, caliper. I don't know. Something here. I mean, the way this works is that when you're creating, I'll just open it up. When you're creating a block diagram, it generally runs from the left to the right, as you might expect, really, I suppose. And another thing you can do to force a structure onto it, to get one thing done at a time, when you're starting out on this, is use something called a sequence structure. It looks like a piece of film. It's a box again, looking a bit like a piece of film. But you'll have a play around with that. And it's a good way to force a structure onto the program. Otherwise, it just goes according to the data flow along the wires. And that takes a little bit of getting used to, of course, because everybody's more or less used to just doing things sequentially. Just do one part of a line of a program, then you do another, and go like that. So getting into this idea of controlling in this way, it takes a little while to get into. Another thing that you don't tend to do in Labview is that you don't tend to use variables if you can avoid it. Because variables tend to, or can, apart from it's not designed for it, they can lead to more memory usage, and also something more serious called a race condition, which I'll explain in more detail later on. You don't want there to be any ambiguity about what's going to happen first in a program, and using variables in Labview could lead to that. So there's something else that's been developed and used a lot in Labview called a shift register, which you're probably not familiar with, but I will spend a lecture talking in a bit of detail about shift registers, because it's a good way of counting and so on in Labview, and you will need to use it in the assignment. Anyway, I don't want to get ahead of myself. This is just a basic introduction to what Labview is all about. The best thing to do is to get into it yourself and have a play around with it. So I think you'll quite enjoy it. I always did when I got learning Labview years ago. So have a go at that. Any big problems, send me an email. I expect everything's going to be okay with you guys. I'll see you later on. Thanks a lot.